All right, welcome. Going to do a little tutorial here just for how to use Excel for the graph that we were putting together. Just noticed that a lot of them were done very well. A couple could have been formatting errors when you were uploading it, but there were just a couple of things, nothing major, just a couple of little details I wanted to provide and show you just how to make the graph sort of as good as it could be, so that you know what we're doing, and because you might have to use Excel in the future. It's a very powerful piece of software, actually. Very useful, especially if you're going to go into the math and sciences. I'm sure that in the post-secondary level, there's lots of better. There's lots of more robust applications, but in terms of doing some simple tasks and simple mathematics and keeping track of graphs and everything, it's very good. Okay, so here's how we go through it. So you can take a look. I got the data here from the textbook online. Hopefully everyone is able to access the textbook online. I mean, we've been doing this for a couple of weeks, so please, if you need to at least try to make sure you can access things, because please account for some technological issues. So if you're required to do something, maybe not a bad idea just to check to make sure it works first and then plan to do it. I know that you have lots on your plate, but please make sure that we are planning things out, because I've been getting a couple things from people last minute saying, oh, I can't get the textbook. So please make sure that you get through any of the issues, and that you don't have to do the whole thing, but make sure that you can access the textbook. Because if you say, oh, I'll do this later, and then when you try and do it maybe a day or two before and you can't access the textbook, then all of a sudden that becomes very frustrating and stressful. So trying to make sure you get all the tech problems out of the way first should hopefully help you with that. I have the data here from this task, right, 3A, asking about zebra mussels in Lake Ontario. So let's just go through the investigation. Basically, I'll give you the rundown of how to do this, and as well as how to put it in the thing, and then this might help you go through. So it says that zebra mussels feed on phytoplankton. Okay, well, what the heck? So zebra mussels we talked about in one of the lessons. These are just mussels, right? They're like oysters or any kind of shelled mollusk. They're just like things that live in shells in water, right? So like oysters, mussels. There's another one, clams, right? Kind of like that. And then phytoplankton, these are like little tiny flecks, small, very smaller than mussels. They are plants and they live in water, and they are microscopic producers. They're single-celled plants, so they're actually quite interesting phytoplankton. They exist in like lakes, oceans. They're pretty much everywhere, and very diverse, very diverse species. So they also live in water. Okay, so it says the presence and productivity of phytoplankton. Okay, so just phytoplankton, so two organisms, right? We got the mussels, we got the phytoplankton. Or just plankton, like in SpongeBob, right? Plankton. Plankton is probably, in SpongeBob, is zooplankton because he is an animal, whereas phytoplankton are plants, right? So there's a bit of a difference there. But the key thing is that they are producers. Remember that producers make their energy, basically plants, okay? The presence of these phytoplankton are often inferred from the amount of chlorophyll A. This is just a molecule in the water. So okay, again, chlorophyll is a molecule, and then that molecule is responsible for photosynthesis in plants. Okay, so what this sentence here is saying is that we can figure out how much phytoplankton there are by looking at the amount of chlorophyll. So what this is telling you is that there's a relationship here. So I can measure one variable, which is the chlorophyll, the amount of chlorophyll, and I can indirectly measure the amount of phytoplankton because of that, right? Science does this a lot sometimes. Like you will have to, in order to measure one thing, that's hard to measure, we can find something else that is proportional to what that is. Hopefully, if you follow me. So basically what this says is that sometimes it's not easy to measure one variable, in this case, how much phytoplankton there is. So maybe we'll look at the amount of chlorophyll, which is easy to measure, and it basically gives us the same information. So the more chlorophyll, you can think that the more phytoplankton there are, right? So this is just adding an extra step. So I know it's kind of confusing reading through this because there's lots of interesting words, but the explanation part of the text of these investigations, of questions, whatever, is probably the most important part of it, right? So understanding this will be helpful. So reading through the whole thing, getting an idea of what you need to do, and then reading through it again, will help you, I think, in future when you do that. Okay, so then we have a table that contains data on the population of zebra mussels and the concentration of chlorophyll A in Lake Ontario from 1990 to 2004. So we take a look at this table right here, and we have, okay, every year from 1990 to 2004, we find out how many zebra mussels there are. This says per square meter, right? So this is basically, we're putting, like this value is literally, I think, just counting the number of zebra mussels, right? Because they're large and they're easy to count. And then you divide that by the area that that it's in. So we look at the table, we have the year from 1990 to 2004, and we see that we have the number of zebra mussels per square meter, and we have the amount of chlorophyll A in micrograms per liter. So this number of zebra mussels is just counting the individual shells of the organisms, and we divide that by the area that they take up, right? So this is giving us how many zebra mussels there are in any given area. And specifically an area that is 1 square meter large. And then the chlorophyll is expressed in a more traditional concentration, which is so this little symbol here is a Greek letter mu, not like a cow, it's like mu, mu. And because it's the Greek letter for like M basically, and we use that for micro, right? So micro just means 10 to the negative 6. It's a metric prefix in order to tell us, just like kilometers, right? The M, the meter, is the base unit there, and we put a K in front of it to imply 10 to the power of 3 or 1,000 of a thing. So 1 kilometer is 1,000 meters, right? Just like one gram is 10 to the power of 6 micrograms, right? Basically a million micrograms. So a million micrograms in 1 gram. So it's just a small number. This is for measuring small amounts of things, right? Small masses. So we have micrograms per liter. So we basically take 1 liter of water, and then we figure out how much chlorophyll we have in there by measuring the chlorophyll mass, right? That was taken out of this liter of water. And we have these values for chlorophyll here, and we have these values for the number of zebra mussels. We have one spot with no data. I don't know why they decided to include this. Maybe there's a very good reason, but I don't know. Well, maybe because these numbers get so small that there's no data, I guess. So you can assume this is 0. I'm not too sure why they didn't just, I think they put no data instead of 0 because they didn't want to assume that there were literally no zebra mussels in any given square meter. So they just said that no data because like basically they couldn't find it. Okay, so how do zebra mussels affect the biotic and abiotic conditions in an aquatic ecosystem, right? Biotic is living, abiotic is non-living. How do zebra mussels affect that, okay? So the prediction says, preview the data in table and make a prediction about the relationship between the two variables. So looking at these numbers, well, this is kind of confusing, right? Because it's just a bunch of numbers. They're organized by year, and it's kind of hard to see any observable pattern. That's why we make that's why we make a graph, right? A graph is an easier way to visually just look at data without having to go through line by line and waste a bunch of time. If I have this nifty graph right here, I can clearly see the trends in how the data proceed, right? So that's why graphs are important, right? You collect data in charts and stuff, but in order to visualize and maybe make inferences, the graph is helpful. So that's why it says organize the data, right? Graph both sets of data on the same graph. Okay, that's important. Be sure to include a key to indicate what each data line represents. So it says both data sets, right? So what we're looking at here is we're looking at 2 sets of data, zebra mussels and chlorophyll. Those are the 2 sets of data that we're looking at, right? They both have the same like time component to them, right? They both have the same year. So since they both have this like year in common, the year is technically not a data set because it's just it's like a setting, if that makes sense, right? It's just the year that we're doing it in. So obviously it's still important. We need to include this time or this year value, but the important thing that we're actually analyzing is the number of zebra mussels and the concentration of chlorophyll. So these 2 sets, right? All of these numbers and all of these numbers we can lump them into 2 different sets of data, and that's what I'm going to be referring to when I say the 2 sets, okay? And then we have these questions here that we can answer once we've done the graph, right? Well, these questions make it a bit easier. The graph makes it a bit easier to answer these questions. Just wanted to give you just a bit of an intro to this to sort of tell you how you know how to do this assignment, this activity. And okay, let's do the actual Excel quick tutorial. now. So this is the finished product, right? I already did this, and this is basically what the graph could, like, just one example of what it could have and what it should have looked like. So I just inputted the values here. I bit the bullet. There's not that many. There's only like 15 entries. So I just went uh, from the textbook here, and I just wrote them down by hand. Most data sets, obviously, if you can port them into Excel, it's nice if you can just copy paste, right? Saves you a lot of time, especially when you're dealing with very, very large sets of data. So there's better ways to do that. But for our purposes here, we're only in grade 9. Let's just enter these 15 things by hand. I don't know if that takes like a few minutes, right? And then I created this graph. So let's look at some of the features of this graph, and I'll show you how to make these features. The couple things. So I have my two data sets graphed separately. Notice that I have two sets of numbers, right? I have numbers on the left and I have numbers on the right here, as well as the year on the bottom, right? That's important, as well as the title for those numbers. So I don't just have a bunch of random numbers. I have this title next to them saying, okay, well, what do these vertical numbers on the left mean? This is the number of zebra mussels, right? And on the right, it's the amount of chlorophyll. And I also have the units of each of those things, right? Per square meter, and then micrograms per liter, right? So I've just taken like the exact titles of what these data sets are, and I've put them on the respective axes. Now, another great thing, and then I've done the same thing. I put year at the bottom, as well as the actual date, as well as the year values. This lets someone looking at this graph know exactly what they're looking at immediately, right? Nice and easy, right? We can figure out what all these values are, and we can see sort of relative how high they are. As well as I've included a title. For me and for our purposes now, the actual content of the title isn't so much as important as just remembering to include it. I feel like grade 9 and grade 10, we're going to try and get you to get these skills in place so that you know how to do this stuff, and then in grade 11 and grade 12, if you decide to take science further, then you can figure out, okay, well, that's a good title, right? Like that, then that becomes the challenge later on. For right now, as long as you're remembering to do this stuff and remembering the proper format for how to make these, that's the important thing. Now, I said that someone looking at this graph can figure it out. Well, that would be incorrect without this legend up here that I've put. So I've indicated that the blue line is the zebra mussels, and then the orange line is the chlorophyll. So this tells you which vertical axis I need to look at to figure out which color it goes, right? So the orange line corresponds with the right, because it says chlorophyll on the right, and then it says chlorophyll is orange. So I can look at all these numbers, and whatever these points are, I match it up to the values on the right-hand side. So this number right here is just below 6, or right on 6. If I hover over it, what is it? 5.9. And then if I hover over here, let's say, the value is 3, which matches up pretty much with this number on the right. Then the blue line obviously follows that, hey, the zebra mussels now are on the left. So all these values on the left, right? 200, 400, 600. This makes sense to do it this way. We need two different axes because if you look at the data, the highest value for the zebra mussels is 1,030, and the highest value for the phytoplankton is 6. Really hard to get those two things so that you can see any difference in them using just one scale, right? So this is part of the challenge of graphing two things on one graph, right? You will need two different y-axes. Remember that y-axes are the vertical ones, right? And then we use the same x-axis, right? So this is two data sets on the same graph. And the reason that we know that they're two data sets is because I have different scales for these values on either side, okay? If you did your graph by hand, you would do this, but then you would pick the scale. You would have to pick the scale yourself, and obviously have to draw this all yourself. So these are all the components that you should be including, especially if you did this on Excel. It's very easy to put these things in. It doesn't take you that much time. And then also if you're drawing by hand, but I think it's a bit easier to remember perhaps if you're drawing by hand. Whereas this, it's tempting just to sort of highlight everything, insert chart, and then think you're done. Let's just go through a quick way that we can do this, just to show you all the intermediate steps now as well. Okay, what I did to make that first graph is what did I do? I highlighted these, and then I went to the Insert tab at the top, and you have a whole bunch of charts on this side here. I was having a bit of trouble with using some of these Excel things and formatting them so I was getting annoyed. So what I decided to do is I decided just to pick a scatter plot. You can use bar charts, line charts. They all mean the same thing. But the nice thing about scatter plot is that I think that the way that Excel does it is it has a neat X and Y. And that's just how my brain works. So if I can figure out what I need to put on the X, I can figure out what I need to put on the Y axis, right? So that's what I did. So I think, in fact, what I decided to do is I only highlighted one set of data, and then I added in the other set. So I selected the scatter plot, which is if you hover over it, then it should pop up XY scatter, right? And then I selected this one because it's sort of like a typical. It's a very typical one, right? So then, boom, Excel does all of this work and then spits out the graph here. But I am nowhere near to being complete. So now, how do I edit this chart or this graph once I've already made it, right? I have a title, and that's pretty much it, right? I have Y values, I have X values, and then I see my little data points here, but it's still not fully formatted. So what I need to do is I need to add in my my other data set. What I'm going to do is I have my graph, and you should see your format chart area on the right hand side. If I go to select data, it brings up this little dialog window here, right, with range details and a whole bunch of what looks like very complicated stuff. All I've done right now is I've made a scatter plot, right, with year and number of zebra mussels. Another thing to point out is that your chart in Excel, the first column will automatically be the X, right? And then the second column will automatically be the Y. Notice how it sort of just did that on its own. That's very handy, but then if you're using multiple sets, then it can be a bit tricky. So what you can do is so again, select data, and I can take a look. So if I hit this section of the chart here, notice how this guy out here is outlined. It's showing me what data it's drawing on to make this chart, right? And then if I click on the name of the graph, right, so where its title comes from, right, where this title comes from, it came from this cell here, right, where I had the name of the thing. Then the X, where I had the name of that data. Then the X values, hopefully you can see this little green dotted line moving. It shows you where it's drawing the X values from, and it shows you where it's drawing the Y values from. What I want to do is I want to add in the chlorophyll as another separate Y value. So what I need to do is I need to make another entry. This is called Series 2 now. What I'm going to call this is I'm going to call this just chlorophyll A. Instead of just typing that whole thing out, I can click this window, this little button here, and then I can click on the cell itself. So it has a reference here for this cell, which has that value. And when I click down, it tells me, it'll say that. And then notice that it's changed from Series 2 to now being called chlorophyll A. What values for X do I want to use? I want to use the same X values I used with my other data set. So I select from 1998, right? I select all the numerical values for the X, right? And then that gets populated. What Y values do I use? Instead of using the zebra mussels, I want to use my chlorophyll values. So I will select this data set. You can also hit enter instead of clicking down, right? And then I have it entered in. So when I hit OK, I see that now I have some orange dots on the bottom, right? I've added in my, my other data set, which is what I wanted. But this is the problem that I mentioned earlier. They're both still using the same scale on the left-hand side only. That's why the orange dots on the bottom, you can't see any trend. They look basically like zeros, right? This means nothing. This doesn't help us in any way. So I still need to format a little bit more. I can do that by selecting the graph, and then I can add a chart element to it. So the two sort of things, and what I'm doing is, this is in the chart design tab at the top. I can talk. Whenever I select the chart, you'll go in between these two, right? Chart design and format. Notice how these are in green. These are green color, whereas these are all in black. So these black ones here are your regular, like your home insert, like regular functions similar to Microsoft Word. But when we talk about the chart itself, we have these two very specific ones, right? We have a format for colors and stuff, and then we also have the design, the breakout. So in the chart design tab, what I'm going to do is I'm going to select the orange data that I want on the bottom, and I should see Format Data Series come up. I can also get to there by right-clicking, and if I've done it properly, then I can get to Format Data Series here. So two ways to get there. Either click on it, and you should hopefully see this, or you can get to this by right-clicking. And then I hit Secondary Axis. So this is what I want to add on. This creates a secondary y-axis, and so now my orange dots, I can see them more clearly against these blue ones. So once I've done this, as soon as I've done that part of it, once I can see my graph properly, it's just a matter of adding in some labels to the graph to get everything finalized. If I want to add lines, I can select the blue data series, and I should be able to see line. If I go to this kind of, again in the format, this little bucket here does pictures, I can hit solid line, and then I can see a line show up. Now I want to change the color of this just because of my settings, and I obviously want to make one blue so that it matches the dots, right? I can do the same thing, click on the orange, this hopefully should come up, line, and then I can go to solid line. Also, notice how it is also blue, which I can quickly change to orange there. Thus, I can see orange dots, orange line, blue dots, blue line. And then my data series looks pretty good. One thing I'm going to do just to go a bit above and beyond is you can see that Excel sort of added in some extra space, 1988 to 2006. If you wanted to change that, if that bothers you, because the data starts in 1990, notice how it says bounds, minimum and maximum, right? So the lowest date is 1988, so I can change that to 1990, enter, and then the graph will shift, right? 1990 will now be the first sort of entry point. And then instead of 2006, I'll go to the last data point, and I'll go to 2004. So again, you can see, remember that there's no blue dot down here because there's no data, but the orange dot now kind of ends on that y-axis. I don't know, I apologize, I can't remember the exact proper way to do this, but having them bound in this would be good, especially because we're talking about specific years, like 1990. Like, it doesn't really make any sense because we don't have any data for 1988. So it might make our graph look maybe a bit more not spread out, I guess, but I think it's fine to have, we can have data points on the y-axis. I don't see why not. Now, why don't we go to the chart design tab, and we can add chart elements. We go to axis titles, right? We want to put a title on the primary horizontal, right? You can see that in the diagram, there's a little line underneath the graph. We hit this, and then we see that the axis title comes up, and I can call it whatever I want. In this case, I'm going to call it, I'm going to call it year. So that's on the bottom title. Then again, I need to get to my chart design, add chart element, again, axis titles. This time I'll do primary vertical, right? You can see that it's to the left now, right? Which again works. And I will call this, I will actually Control C, and I will Control V there. My zebra mussels will be on the left, and I can double check that because look, that's 1200 and that's 1130, so this is the right scale, right? Then I will do the same thing, chart design, add element, axis titles. This time, I don't need a secondary horizontal, I need secondary vertical because it's the other y-axis on the other side, and then that will show up. I'll do the same thing, Control C, and then Control V in here to save myself a little bit of time and typing. You can put these any way you want as well. If I just select this title here, then it should have an option of vertical alignment center left. I can move it around, I think, if that didn't really anything, rotate the text. I can make it horizontally instead so that you can read it kind of better, but then it takes up a lot of space, right? So it's really up to you what you want to do. You can do it. You can rotate it so that it's like this, right? So that it's sort of the same way. I think that works fine because you don't really need to read this specifically because you can see the title over there, I suppose. So we have, look, label, 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 which is really good. We have our graph actually looks a lot better. We need a title still, so chart design, chart element. We should see axis titles or chart title above chart wherever you want to put it, and then you can call this title. You could just say zebra mussels and chlorophyll A. So that's what we're looking at. You don't have to be crazy with these titles. Just call it what it is, right? Because that's what the two things that we're looking at. against time, really, and chlorophyll A by year, perhaps, right? By year. It just might be a bit of a better one. So that incorporates all three things that we're looking at. We're looking at year, and we're looking at this much, and we're looking at this thing here, okay? But just pointing out that my title here, Zebra Mussel Population Compared to Chlorophyll Concentration by Year, is obviously a much better title than this, but we're not going to focus too much on that. Then, what's the last thing that we need to have? We need to have a legend. So we select the graph. Notice that the chart design and format disappear. If I select a cell, then they kind of go away. So I need to hit that graph, and then they will come back. And then I can add another element. I believe it's title, or is it data labels? Not labels. Legend. And then we have a legend, and we can put it sort of wherever we like. Maybe we'll put it on the bottom down here. And then it will add it in automatically, right? Blue series is number of zebra mussels, which makes sense. And then the orange series is the chlorophyll, which also makes sense. And then that's it, right? The key components of the graph always needs to have something on it, right? That's done properly. Scale needs to be done well. You need to have a title. You need to label everything. And if there's multiple data sets, you need to add a legend of some kind. If you don't have other colors and you're doing this by hand, you could do one as circles and one as X's, right? That is easy to see. Or one as circles, one as squares, whatever. Something that makes it easy for someone just to look at it and know what it is, right? That's the reason we do these things. Basically, you're thinking about what someone who doesn't know what you're doing, how they interpret what work you've been doing, right? Okay, that's the tutorial for Excel on how to make that chart, as well as how to answer the questions, right? So then we have these three questions here. You know what? While we're doing this, let's just go through this quick. So number one says, explain the relationship between changes in zebra mussel numbers and the concentration of chlorophyll A. Well, if you look at the graph, you can see that I'm going to close this, more or less, zebra mussel populations goes up over here, and what happens to the chlorophyll? The concentration starts to go down, right? We see a dip down here at the zebra mussel's peak. But then what happens? Zebra mussel population starts to go down again. So what happens afterwards? Well, now the chlorophyll concentration goes up, right? And then as the zebra mussel population kind of plateaus almost near zero, we see a steady kind of increase in the concentration of chlorophyll. What does that tell us, right? So all we have to do is explain the relationship, right? We don't really need to do too much analysis, but basically the relationship there is just we're looking at the two sets of data. As the one data set increases in value, in number, the other data set goes down, right? And then vice versa, right? Then as the blue one goes down, the orange one goes up. That's basically it, right? That's all that we need to say for number one. What's the relationship there? As the number of zebra mussels increase, the amount of chlorophyll goes down. This makes sense because it tells us that zebra mussels feed on phytoplankton, right? If we know that zebra mussels feed on phytoplankton, if there's not as much phytoplankton, there's not going to be as much chlorophyll, right? So again, indirectly measuring how much phytoplankton there are. Number two, infer how zebra mussels change the biotic conditions in an aquatic ecosystem. How could the changes affect the biodiversity of the ecosystem, right? So zebra mussels are an invasive species. They eat all of the phytoplankton. If there's not as much phytoplankton around, that will potentially decrease the amount of biodiversity because other stuff probably eats that phytoplankton, right? In a balanced equilibrium. So if there's not as much phytoplankton to eat, other things will die, therefore decreasing the biodiversity, right? So that's the biotic effect that the zebra mussel can have on this condition by eating all of the food, by eating other organisms, by depleting other organisms' food sources, okay? That's a biotic change in the ecosystem. Specifically because we know that zebra mussels are invasive species, right? It talks about that in the chapter. As well as get information for this will come from the preceding preceding chapters, right? So if you need more info on this stuff, just read through the previous pages of the textbook. When the number of phytoplankton in water decreases, clarity of the water increases, light can penetrate deeper into the water as a result. How might this change abiotic conditions in an aquatic ecosystem? How might this change to abiotic conditions affect the biodiversity of the ecosystem? So we see that more light penetrating deeper in the water can raise the temperature, which can affect the organisms that can grow there, right? Because they can only grow in certain temperatures. Okay, so that's the video. Great, thanks so much. Hope this makes sense. Let me know if you need any help with other tutorials.